Okay, what if the very foundations of science are just wrong? And I'm not talking about some tiny little error. I'm talking about a huge, fundamental misunderstanding of reality itself. In this explainer, we're diving into a pretty radical idea, that there's a deep crack in the bedrock of both physics and mathematics, and it all starts with something we all learned in elementary school.
So here's how we're going to break this down. First, we'll look at that crack in reality. Then, we'll get to the core idea, what's called the perspective problem. After that, we'll see how this creates what the source calls useful fictions in math, how it leads to some pretty big gaps in physics, and finally, what a new scientific toolkit might look like to fix all this.
All right, let's jump right in. Section 1, a crack in reality. This is where the whole thing kicks off, and it starts by questioning something that probably feels, well, completely unshakable to you, a concept we all take for granted.
Just picture a number line, the one from school. We're taught it's this perfectly smooth, continuous thing, right? Like you can pick any 2 points, zoom in, and there's always another number in between. You can do that forever. Well, here's the bombshell claim from our source. That whole idea, it's a fiction. It's not real. In actual physical reality, there's no such thing as a truly continuous line.
So you can see how this immediately opens up a massive can of worms. I mean, if something that basic, the number line, is wrong, then what else are we getting wrong? This isn't just some abstract math puzzle either. It has huge real-world implications for how we describe the entire universe. And that really brings us to the heart of the matter.
Okay, Section 2, the perspective problem. Now, to really get why the number line could be a fiction, we have to understand this one core idea. It's a crucial distinction that, according to this theory, modern science just keeps missing. And this lays it out perfectly. On one side, you've got absolute reality. That's the whole shebang, the underlying machinery of the universe, chugging along completely unseen and unfiltered. Then on the other side, there's our human perspective. That's just the tiny slice we get to see and measure with our eyes, our ears, and all our scientific gear. We never see the complete engine room. We only see what's happening on our little dashboard.
And this is the fundamental mistake that the source points to. Science gets into deep trouble the moment we start confusing our limited perspective with absolute reality. It's like we build a really good map based on what we can see, and then we forget it's just a map and start believing it is the territory itself. That's the core problem.
So, what does this map versus territory problem actually look like in practice? Well, let's start with math. Section 3. Math's useful fictions. This is where we get to see the direct consequences of this perspective problem. Think about the big ideas in math, especially calculus. You've got the continuous number line, the concept of infinity, and those teeny tiny things called infinitesimals. They're basically the foundation of a huge chunk of modern math. But the argument here is that none of them are actually real. They're not features of the universe. Instead, they're incredibly useful fictions. They're brilliant tools we invented from our limited point of view that help us make our equations work, but they don't actually describe what's happening in absolute reality.
Okay, so if these things are fictions, what's the alternative? The source actually proposes a new mathematical idea, a new object, called in-between. It's a really interesting concept. Think of it as a way to formally put a name to the gaps in our knowledge. It's like a placeholder that says, hey, there's stuff here we can't see or describe perfectly. By acknowledging these gaps, it actually helps explain why our fictional tools like infinity are such good approximations without us having to trick ourselves into believing they're literally real.
All right, moving on to Section 4, physics and its gaps. And this is where things get really serious, because if the math we're using is built on these useful fictions, you can probably guess what happens when we use that math to try and explain the physical universe. Yeah, you end up with some pretty massive headaches.
And the consequences really are huge. The source claims that our best theories in physics are riddled with these gaps. For instance, we can describe how a particle behaves with incredible accuracy, but we have no clue about the underlying machinery that's actually making it happen. Why does it do what it does? We don't know. The theory also argues our entire definition of time is way too simple. And maybe most shockingly, that our two crowning achievements, quantum mechanics and general relativity, are fundamentally misinterpreted. We think their equations are telling us about absolute reality, but what if they're just describing what's visible from our very specific, limited perspective?
Let's take time. It's a perfect example. For us, here on Earth, we experience local change. The clock on the wall ticks forward, we get older.
But now think about a photon, a particle of light, zipping across the universe. From its own point of view, 0 time passes, not a single tick. And yet, it still changes, it travels, it interacts. So how is that possible? Well, the source suggests there's another kind of change, global change, a fundamental change in reality itself that's happening at a deeper level, one that our little ticking clocks just can't measure.
And when you start thinking like this, it leads to some pretty profound philosophical places. For example, we usually think of the universe in terms of cause and effect, right? A causes B, which causes C. Simple. But what if that's only half the story? The source suggests that our normal causal reasoning and a more purpose-driven or teleological reasoning, what if they're not opposites? What if they're just two sides of the same coin? Two different ways of looking at a single process happening in that deeper, absolute reality.
Okay, so we've laid out all these pretty huge problems. The big question is, what do we do about it? Where do we go from here? And that brings us to our last section, Section 5, a new scientific toolkit. This is the proposed solution, a new way of thinking to get us back on track.
The core idea is to be incredibly disciplined about the jobs of each scientific field. Think of it like a 3-step process. Step 1, you have mathematics. Its job is simply to describe the patterns we see from our human perspective. That's it. Step 2, you have physics. Its job is to try and explain the real underlying machinery that's creating those patterns. And finally, Step 3, you have philosophy. Its job is to provide the framework to understand what it all means and, most importantly, to act as a referee to make sure we're not mixing up the jobs of math and physics.
And really the whole point of this new toolkit is just to draw a big, clear line in the sand between our models and reality itself. It's about constantly reminding ourselves that the map is not the territory, the equations aren't the universe, the numbers we write down aren't the actual things they're measuring. If we can just keep that separation clear, we can stop confusing our beautiful but ultimately incomplete descriptions for the real thing.
Which, of course, leaves us with one last, very powerful question to think about. If we actually start doing this, if we really start separating our limited human perspective from whatever absolute reality might be, what other fundamental truths of science might start to crumble? What other bedrock ideas are actually just artifacts of our unique point of view? What else are we looking right at, but not really seeing at all?